Let's talk about calculus and area. So calculus and area. Area is one of the two major questions that calculus tries to answer. So what we're going to do to begin talking about area and calculus, and this isn't going to look like it has calculus in it at all, but we're going to estimate area under a curve. Now, if you look at a curve, and I'm going to just give you a curve of something like this. F of x equals y is equal to 4 minus x squared. So if I have that, I've got 1, 2, 3, 4, and then out here at 2 crosses the x-axis. So that's a parabola that opens down. I didn't make it very curved, but anyway, that's approximately what it looks like. And it does the same thing on this side, okay? Let's find the area from x equals 0 to x equals 2. Now, we're going to approximate this, and this is going to be a lousy approximation. I'll let you know that right off, but let's say we're going to use rectangles, because we know about rectangles from geometry formulas. So let's use 4 rectangles. So that's what I'm going to do. Now, I'm going to make 4 equal size rectangles, which we don't really have to do, but it's easier. So let's divide this value from 0 to 2 in half and make a vertical line. Then I'm going to divide each one of these in half, make vertical lines. So there's a vertical line, there's a vertical line. I have 2 choices. I can run the top part of the rectangle outside of the graph, or I can put it inside the graph. So if I make it inside the graph, that is the same thing as what's called inscribed. If I run it outside, then that is what is considered circumscribed. Okay, so that's what we have. I kind of like inscribed. I don't know why, but I do. So this is going to be, like I said, not terribly accurate because I've only got 4 rectangles that I'm going to try to create. But if I do this, my first rectangle is that high, my second rectangle is this high, my third rectangle is this high, and my fourth one is this high. Now this one doesn't even count because it doesn't even have any area. But I know that this is at 0, this is at 1/2, this is at 1, this is at 3/2, and this is at 2. Because I divided 0 to 2, a 2-unit region, by 4. And then I know that these run into the function here, and here, and here, and here. So my 4 rectangles, let's look at the deal that works with these. My rectangle number 1, and I'm going to use lowercase letters, rectangle number 1, is going to be right here. It is going to have width, and it's going to have height. The width is going to be 1/2. In fact, rectangle 2 will have 1/2 width, rectangle 3 will have 1/2 width, and actually rectangle 4 has 1/2 width. Now what about the height? Well, this one comes up right in here, runs into the function. It's where x is 1/2, so this would be f of 1/2, which is 4 minus 1/4, 1/2 squared, which is 7/4. No, it's not. Let's try 15/4. Okay, 15/4. This one, r sub 2, second rectangle, that's this one, r2. So that one's going to be at f of 1, which is 4 minus 1 squared, which is 3. This one is going to be at 3/2 right here. So f of 3/2, which is 4 minus 3/2 squared, that's 9/4. So 4 minus 9/4, That's 16 fourths minus 9 fourths. That one's 7 fourths. And then this one has value, runs into the function right there, so it's at f of 2, which is equal to 4 minus 2 squared, which is 0. So it's 0 high, so that's no big deal, but it's not really going to count anything. So if we take these, width times height is the area, so this one's 15 fourths times 1/2. It's 15 over 8. This one is 3 times 1/2, so this is 3 halves. This one is 7 fourths times 1/2, 7 over 8. And this one's 0 times 1/2, so this one's 0. So if I add all those up, what I get is I get 15/8 plus 3 halves plus 7/8 plus 0. Well, 15/8 and 7/8, that's 23/8. They had common denominators, so I put those together. Let me put this one in eighths. So I multiply top and bottom by 4. That's going to give me 12/8. So plus 12/8. And so now 23 and 12 is 35/8. So 35/8, 32/8 is 4. So this is 4 and 3/8. So that's our estimate. Now, that's not that great, but it's an idea. What we did was we left this space, this space, this space, and this space with no value in them, so we really don't have as much as the area under the curve.